Good morning, good afternoon, good evening to all. Hope everyone is doing well. It's been a while since I've done a noon show because I've been doing the trial. I want to try something different. I don't know. I appreciate the invite and being able to do that, but I like you guys so much better doing stuff like this. So I don't know. There'll be some more choices coming up for trials and stuff, but I'll probably stick more to this, or at least do this, and then work that around the trial. I feel like I sound really low. Hang on one second. Let me... Now I think well, no. Why do I sound so low? Chat, do I sound low? Here, let's see if that works. Is that any better? Let's see. Yeah, that seems to be a little bit better. Weird. I don't know. We'll see. We'll play with it and see where we're at, but that sounds a little bit better to me. What's up, Stevie? Say hi to everybody, then we'll get going. X-Comer, good to see you, buddy. Impish, good to see you. What's up, the Pineapple Man? What's up, Jonathan? Yeah, toddlers and all little kids are germ bags. Ba weep gran weep ninny bong. Same to you, friend. Yeah, I think that's the better option. Let me hang on one second, guys. I apologize. I want to... Let me turn off crisp. Let's see if that's any better. That doesn't even seem any better. Yeah, I put something on real quick. There, now I think we got volume back. What's up, Snafu? Yeah, might summon something. What's up, Greedy? I think the volume is better now. I'm actually going to listen in real quick just to make sure. Because it's driving me nuts. I don't know, like... Yeah, now it's a lot better. Okay. That's the other downfall to going on other people's streams is your audio gets all screwed up. So... X-Comer out the gate, buddy, with a rumble rant for some ice cream on your trip. I appreciate it, sir. God, I can't wait to be in a place where I can actually eat ice cream and not be freezing to death. That would be awesome. So, what's going to happen next week? Next week, I am going to be gone the entire week. I saw it, Kaiser. I just addressed it, buddy, but thank you. I'm going to be gone the entire week. last I heard, hey Jude, good to see you. Last I heard is Valhalla is going to have some guests on to fill some time during the week. I will be taking all my stream equipment. I don't know how the setup's going to be. I will, if nothing else, check in with you guys during the week. Probably drop in Discord a time or two. So I'm not just going to disappear. But yeah, I'll be around. Just not as frequently as I have been. So, all right. So today's, I wanted to talk about Universal Greeting from the original Transformers animated movie. Oh, okay. When am I gone? I'm leaving tonight / like late tonight-ish. There will still be a Lego stream tonight. I gotta finish building my train Lego that I started last night on a stream with Kaiser. So, we'll be doing that. And then I'll stream from the beach a couple times. Just because, why wouldn't I? Also plan on running into the great Mr. Steve Gosney while I'm down there, so I'll try and do something with him too. Oh, your God, what? Yeah, 20, 22, something like that. So, I figured it would be a great day to let my Tokyo Gore Police stingy. Some of the things that you send me are so weird. So weird. But I appreciate it. Keep it coming. Checking up on Discord. I apologize. So, that's what I just said. I will stream at least a couple times. So, yeah, I mean, it looks like it. I probably did, because I was kind of rushing to get it done, so so we did, it was over 2 weeks, but we did 4,000 miles across the entire country, so that was pretty rough at the end. Seriously? You're gonna try and grift and steal my viewers, Kaiser? It's BS, man. BS. So, let's get into the topic here in Florida. Okay. Introduction to Lanthanide. These are my favorite metal group, because they're so fun. They're fun to play with. So we're gonna, I figured we'd break down some of the periodic tables, things like that, because it's interesting. So why wouldn't we? So this is the periodic table. Lanthanides are right here. So there's this top group with some cool stuff. I also like the... Okay, I gotta stop the freaking Discord from beeping. It's driving me crazy again. stingy. I also like the actinides. So, these are my favorite. Okay, sounds good. I'll keep my eyes open. So, it's this group. There's some fun stuff in here. They're considered rare earth elements, but they're more common, and we'll get into that. So this is what they look like in these tubes, for the most part, in different oxidation states and stuff like that. So, what are lanthanides, aka rare earth elements? The lanthanide series is a row of elements situated below the main block of the periodic table, within the F block among the actinides. They are all metals. Lanthanides occupy elements 57 through 71 and branch off after barium on the periodic table. Their electronic configurations are much like transition metals, but with the fourth electron shell that can hold 18 electrons. And that just talks about the element and how stable it is. So, they possess similar properties to transition metals, but have some unique characteristics and applications. No, you're fine. I don't stay on point either. We know this. The lanthanides, along with scandium and ytterbium, are also known as the rare earth elements. Here's some common characteristic properties. Are commonly found in earth crust as components or compounds with other metals. So they have to be separated out. Lanthanides are reactive and form ionic compounds with nonmetals. And that means that they're fun. Not to pee and bleach. Lanthanides tarnish, meaning they quickly lose their shine, luster when exposed to air. Lanthanides are stored in oil or noble gases to prevent tarnishing. Lanthanides are solid STP. Most lanthanides only use 3 electrons as valence electrons. Rare earth elements are quite difficult to tell apart as they have similar physical and chemical properties. Rare earth elements have unique electronic and magnetic properties which allow them to occupy special niches in technology. They are all metallic and look silvery. Don't be fooled by the name. Rare earth elements are not particularly rare. Cerium is the 25th most abundant element in the Earth's crust, more common than copper. Monazite is a group of metals or minerals that contain the highest concentration of rare earth elements. Monazite usually contains the phosphate of cerium, lanthanum, neodymium, samarium, or I can never say this word, praseodymium. It also often contains thorium, love thorium, and sometimes uranium, which makes it radioactive. Monazite is found in Brazil, India, South Africa, Australia, and the United States. Extracting rare earth elements from monazite is an extensive process requiring many filtrations and neutralizations. So it's a lot of work to break them apart. Yeah, lithium is a solid. So how many rare earth elements? Yep. Which is a serious geopolitical problem because China has a lot of these. So how many rare earth elements actually exist? The answer is 15 or 17, depending on how you define it. If you include scandium and ytterium, there are 17. If you don't, and include true lanthanides, there are only 15 rare earths. The reason scandium and ytterium are often included is because of their physical and chemical properties that are similar to true lanthanides, and they are found in the same ore. Well, message me in Discord, baby. Okay, so lanthanum. The name lanthanum comes from the Greek word lanthanium, which means hidden. It was discovered by a Swedish chemist, Carl Gustav Massander, in 1839. I don't understand how they separated all these things and knew about them with that kind of technology back then. It doesn't seem like it doesn't seem plausible. So, seems like there's a lot of guessing going on. It is soft enough to be cut with a knife, ductile, and has a silvery color, which most of these do. Lanthanum has numerous industrial uses, including ignition of torches, lighters, and blowpipes. It is also used in electron cathodes and light bulbs to prevent yellow light from being emitted. Yeah, by absolute pure accident, so. Alright, have a good dinner, greedy. So that's what our lanthanum looks like. And it looks a lot like a sodium or many other. Cerium, element 58. Cerium has a physical property similar to lanthanum and has a similar appearance as well. It is by far the most abundant lanthanide in the Earth's crust. Cerium was discovered by German chemist Martin Heinrich Klaproth in 1803. I just don't. Yep. It's named after dwarf planet Ceres, which orbits the sun between Mars and Jupiter. Cerium readily reacts with water and halogen elements. Cerium-based compounds are used to polish glass, but are also used in catalytic converters and LED lights to produce white. Most of these are far more reactive with water. Far more fun if you put it in water. So that's cerium. You can't really tell a whole lot of difference. They're pretty close. Yeah. Praseodymium has similar characteristics to cerium and lanthanum, a pattern that will continue through the survey of lanthanides. However, it has much more potent optical, electrical, and magnetic properties. It is too reactive to occur naturally in its pure elemental form. Praseodymium was discovered by Austrian chemist Baron Karl Alval Waschbeck while separating different colored salts. Unlike many other rare earth metals, praseodymium is paramagnetic at all temperatures. Praseodymium is used in a wide variety of applications, from ceramic stains to wind turbines to high-powered magnets. So that's one of those ones that that has an application in magnetics, but isn't as stable and is much more difficult to have. So then we get into one that you probably know pretty well. Neodymium shares many physical and chemical properties with the lanthanides, but unlike its other periodic table companions, neodymium is capable of displaying multiple colors through oxidation states. So it's fun to play with. It produces pink, blue, and yellow oxidation states of +2, +3, +4, respectively. And oxidation states are how much oxygen attaches to the chemical element. So, most of the naturally occurring neodymium on Earth is in Eastern Asia, China. It was also discovered by Welshbach in 1885. The most significant use of neodymium is in electronics. Neodymium is able to form strong magnetic alloys with other metals. These alloys are used in a wide array of modern technologies such as speakers, microphones, and headphones. Large neodymium-based magnets are found in electric motors of hybrid cars. Neodymium is one of the most influential and important elements of the 21st century economy. And you get neodymium, a blend of neodymium, in things like magnets. So I have... Get off the... Just a second. Oh, stop it. So that's like my default setting now, is that stupid freaking thing. So, everybody's seen neodymium, and this is a neodymium magnet, so, but just to see it again. There's just, you know, this shiny, metallic looking thing, so. Excomber, it's just a magnet, buddy. Alright, Promethium. Promethium is one of the rarest elements on Earth. It is estimated there are only about 500 grams worldwide occurring in the Earth's crust. However, it can be produced in laboratory by bombarding uranium-235 with neutrons at very high speeds. This produces Promethium-147, the only isotope of the element with practical applications. But with only 500 grams, it's not very practical. It was first synthesized by mistake at Oak Ridge National Laboratory in Tennessee, which was recently on fire. Relatively little chemistry is known regarding Promethium because it is so unstable and thus difficult to study. Outside of research, the only use of Promethium is in atomic batteries. So, if you're talking about nuclear batteries, Promethium is probably the element that could make it happen. However, with only 500 grams, it's not viable. So there are different things that we could, you know, use that would be effective. They're just not. You didn't hear about the fire at Oak Ridge National Laboratory in Tennessee? There's a big fire. They say it was under control, but So we have things like Promethium that would be good in applications. They're just not viable because we don't have enough. Samarium, element 62, Samarium has the same silvery luster as fellow Lantahnides, but it's much harder and somewhat more ductile. It also oxidizes in air, but much more slowly. Samarium is found in some parts of the Earth's crust, with concentration as high as 3%, making it relatively abundant. French chemist you pronounce his name discovered, isolated, and named the element in 1879. Like its cousin element, neodymium, samarium is used to construct high-powered magnets, but samarium-based magnets are capable of withstanding greater temperatures. And with that comes expense. So, that's why you don't see them in many practical applications. Yeah, so it has a relatively short half-life, so even if we did use it, it would not be terribly effective. Unless we could somehow stabilize it with a different element, so. Am I near Quebec? No. I mean, not... I'm quite a ways from Quebec. Let me see. I'll tell you. I'm 12 hours from Quebec. So those are stronger neodymium magnets. So that you don't, I wouldn't stick your fingers between. So, Europium. I love Europium. Europium is by far the most reactive lanthanide. Its high reactivity requires it to be stored within inert fluids to prevent it from reaching the air. Europium reacts with all halogens and forms stable compounds with I can't pronounce anything today. Nope. Well, I got the dumb joke, but like Samarium, it was discovered by, I can't pronounce anything today, Bois Berduran in 1892. Unlike Samarium, it is very soft and malleable. Europium is one of the rarest elements on Earth. Pure Europium does not exist in nature. It must be mined from minerals such as monzonite. Europium does not have numerous applications as other lanthanides, but is used in many optoelectronic devices such as lasers and fluorescent lamps. So this is Europium. This is a Europium powder. It glows in the dark. It's really cool. And it's in a container. But really cool stuff. Really reactive with air. Like if I were to break the vial, it would produce a pretty spectacular fire. Why do I have this stuff? Why don't you have this stuff? Xcomer, at points I think that you really like me. And then at other points, I think that you want me to either die from fire or my wife. I choose fire if I have a choice. Gadolinium. Gadolinium possesses physical properties more similar to cerium and praseodymium than europium at temperatures above 20 degrees Celsius. It is the most paramagnetic element on the periodic table. An oxidized form of the element can be found in nature. Gadolinium was first discovered by Swiss chemist Jean-Charles de Menarac in 1880 and was later isolated by Boissebaudin. At high temperatures, gadolinium forms binary compounds with many nonmetals. It also serves as a strong reducing agent in laboratory experiments. The only known industrial use of gadolinium is shielding within nuclear reactors. Yeah, that's what I thought. So they use a newer one. I just wanted to check to be accurate. A newer one that they use it for is contrast for imaging. So, like brain imaging to find tumors and stuff like that. So, and that's what it looks like. Terbium has similar properties to Europium. It is also exclusively found in minerals such as cerite, monzonite, and exunite. Terbium was discovered by Swedish chemist Carl Gustav Mosander in 1843. Terbium is an electropositive element that reacts with water, halogens, and strong acids. The one use of terbium is in industry as a stabilizer in high temperature fuel cells. It is also used in the production of electronic devices such as sonar systems and color TV tubes. Dysprosium is a highly magnetic lanthanide. Its characteristic magnetic properties are made strongest when temperatures are very low. So this is a good one for very cold temperatures. Supermagnets. It is the lowest tarnishing lanthanide. This guy remarked on how difficult the element was to isolate with acids, subsequently naming it the Greek word for dysprosium, translating to hard to obtain. The main application of dysprosium is magnets in wind turbines. So a lot of very magnetic properties with a lot of these elements. Holmium. Holmium's underrated. It's a lanthanide that's been discovered by Swedish chemist Theodor Cleve in 1878 via isolation. It is too reactive to occur in nature. However, it is relatively stable in very dry conditions at room temperature. And that's a common thing. A lot of these don't like water. It is mined from minerals using techniques known as ion exchange. Like many other lanthanides, holmium is strongly magnetic. Very strong magnetic. It also has the relative unique ability to absorb large quantities of neutrons, making it a very practical material to include in the construction of nuclear reactors. So holmium and the rods can bring out a lot of the neutrons to stabilize a nuclear reaction. Erbium is a silvery white lanthanide found in Ytterbium, Sweden, hence the name. The Er3 ion gives off a fluorescent pink color, which is readily absorbed by water and biological tissue. This makes erbium well suited to be used in surgical lasers. Others include metallurgy, as it forms strong bonds with the metals in the fourth row of the periodic table. So it likes fourth row metals. Thulium is a silver-gray lanthanide, which is also discovered by this dude. It is the second rarest lanthanide after Promethium at very high temperatures. Thulium functions as a superconductor. It is also used as a source of radiation in small X-ray devices. Thulium-170 is currently being researched as a radiation source for cancer treatment. And Ytterbium, silvery yellow metal that serves as a penultimate lanthanide. Like the other late lanthanides, Ytterbium is capable of forming complex with 9 water molecules when placed in an aqueous solution. Many properties such as melting point, boiling point differ significantly from other lanthanides due to its closed shell electron configuration. Ytterbium has a wide array of applications from nuclear medicine to metallurgy and in the construction of atomic clocks. So now we'll look at Europium catching fire. Yeah, 69 noise. Stop. Let me see. Oh. No, that one's boring. I want to see it, like, violently react. Europium, water. Hang on, I'm looking for one that's really good. Ah, damn it. Can't find that one I was looking for. I hate this guy's voice, but we'll watch this video real quick. It's like 2 minutes.
To look more closely at the lanthanide elements and their chemistry. For now, let's shrink the main table. First of all, the lanthanides are all metals. Here's a selection. Here's lanthanum, Samarium.
See, they all look very similar.
If it's heated in chlorine, Dysprosium forms a trichloride, and all the other lanthanide metals do the same. Chlorine oxidizes all of them to the +3 oxidation state. But the simplest way of reaching this oxidation state is to dissolve the metals in dilute acid. Here's Praseodymium. Hydrogen is evolved, and if the reaction is done in air, then whatever the lanthanide metal, the final product is the aqueous tripositive ion. In this case, it's green. Compounds or ions in other oxidation states are much less stable. For instance, the dye-positive aqueous ion of samarium can be made. It's blood red. But it's quickly oxidized by water or hydrogen ions to the pale yellow tripositive ion. The highest known oxidation state of any lanthanide element is +4. The most stable example is cerium 4, which occurs in cerium dioxide. This is almost colorless. Sulfuric acid converts the dioxide to a sulfate of cerium 4. It consists of orange crystals. When the orange sulfate is dissolved in water, the orange tetrapositive aqueous ion is formed. But even cerium 4 species are easily reduced to the +3 state. We'll use hydrogen peroxide as the reducing agent and add it to the orange aqueous ion. Oxygen is evolved as the cerium 4 is reduced. The colorless product is the aqueous tripositive ion of cerium. So for all of the lanthanides, the +3 state is very stable to oxidation or reduction. The lanthanide series, which begins with lanthanum and ends with Ytterbium, is a set of unusually similar elements. Take a little time to study the pictures and information that we've provided on the different metals. And as you examine the reactions with acid, ask yourself how these elements differ from the reactions that you studied earlier in the transition metal program.
So yeah, that's a quick breakdown of different metals. And the large. So I think these ones are really cool. Mostly magnetic. And they play well with other things. We use a lot of them. The next series, and the actinides. Yep, go for it. Yes, trans metals, because we're inclusive. The actinides are all very radioactive, and they're kind of like their old cousins. They're, so they're really cool to look at too. And we use them in everything. I can't find any europium in air. Hang on, let me try one more time. I was trying to just play something that I had to not bore everybody to death, but here. Dimethyl zinc. Hang on. Yeah, we'll steal this from Thorsium. Thor's Eye. I'll probably get struck for this, but that disclaimer says try it, it's alright. Now I'm gonna have to waste my Europium sample. Damn it.
Hello everyone.
Not
Today I would like to tell you about such an unusual metal as Europium.
This guy's voice is terrible. But maybe it's not as bad as I think. I'll leave the closed captions on.
Europium is a pretty active so-called F metal belonging to the Lanthanide series in the periodic table of chemical elements. This is a very active metal, and its chemical activity can be compared to that of lithium. That is why it is stored in containers.
He's not Russian. He's I forget where he's from, but he's not Russian. He's I think he's Czech, maybe. I don't remember. He tells us at some point. He's a good watch.
With inert atmosphere to protect europium from oxidation. By the way, europium metal is paramagnetic and gets attracted to powerful neodymium magnet, and also this metal is very expensive. I paid $20 for 1 gram of this metal. When taken out of its container, europium is a shiny metal that quickly covers in its oxide and yellow europium carbonate. This separates soft metal. Europium can easily be cut with pliers. Its softness
And that's a stable metal form, so not the powder. So
can be compared to that of lead. Europium actively reacts with water like lithium or calcium, forming polysoluble europium hydroxide of yellow color. As time passes by, the metal covers in thick layer of hydroxide and the reaction slows down. If mixed with hydrochloric acid, the reaction significantly speeds up, because europium dissolves in hydrochloric acid very well, producing yellow europium chloride.
I don't have enough guts to play with hydrochloric acid as ridiculously as he does, but someday maybe.
Right. By the way, I was surprised by the property of europium chloride. Freshly made solution of this substance fully blocks ultraviolet light when being pointed at with an ultraviolet laser, which is pretty strange, because usually europium salts glow in ultraviolet light. This effect is well observed if one tries to pass a beam of ultraviolet laser through europium chloride solution, with a flask filled with luminophore solution behind it, from green emitting luminophore. Even more interestingly, when the solution had been stored in a dark place for a couple of days, it began glowing red-orange in ultraviolet light and stopped blocking ultraviolet laser beams. I think this effect is somehow linked to the fact that the radius of europium atoms is large and the atoms have f orbitals. Let's move on. If you mix alkali or sodium hydroxide with europium chloride, it will form.
So the reason why europium, because it's is incredibly flammable, is it releases hydrogen gas. So sorry, I'm just blacking the video to. So when it reacts with air, it breaks the bonds of the air or water. It breaks the bonds, attaches to the oxide, and then releases hydrogen gas. So
form yellow sediment from europium hydroxide. As many other lanthanide hydroxides, europium hydroxide dissolves in trilon B, a teapot limescale remover, forming soluble agent. If you try to set a piece of europium metal on fire out in air, despite your expectations, it wouldn't burn, although its chemical activity should cause it to. I think it's so due to the high melting point of this metal.
it won't burn in the metal form. Like I said, it's got to be the powder. So
upon piercing europium in air, it forms europium oxide that also gives the flame of the burner a red color. This oxide, as well as europium chloride, glows red in ultraviolet light. Europium oxide, as well as its other compounds, make up well-known luminophore powder based on strontium aluminate. These differently colored powders that are abundantly sought via the internet have a unique property.
like they're so cool. Like to
Such powder glows in ultraviolet light and also accumulates light energy, and it can glow for a few hours after the light was turned off. Such powder are used in applied arts, and they are also added to lost dyes, especially those that are used to paint.
yeah, so they'll keep the light signatures like that. So it's really cool.
Hand tips that glow in the dark. Europium is an afterglow activator in such powders, and it also increases brightness of the residual light. The color of the powder depends on its content. To get other colors, other rare earth metals compounds are added. Europium oxide is also used in picture tubes to make red pixels, and also in order to make fluorescent lamps light warmer. Europium is also used to protect the dies of euro banknotes. Europium protects euros. What an interesting coincidence. Perhaps Californium is used to protect dollars. If you will.
No, hopefully not. So yeah, it's it does. It sounds like borat. So it does produce a ton of different things. Sorry, I'm distracted. I'm gonna have to burn my powder just to show you. I don't know if I want to do it though. I'm not doing it today because I don't want to get in trouble with the wife. But yeah, probably. At some point I will. This is and we'll end with this video. This is also from him. These are different experiments you can do with different stuff. So chemical clock, fluorescein, barking dog. Has anybody ever heard of the barking dog? That's one I could probably do too. So cool. Thiamine borate. Sodium. Sodium explodes. Huh. I've never seen that one before. The lead iodide. Acetone flashlight. Phosphorescence. Those are so cool. Nitrocellulose. I know you like things like a boom. I do too. Steel wool burning. So he's a good channel to check out too. Yeah, so, and I'm just checking because I want to make sure that I'm correct. Reacts with water and air, liberating flammable hydrogen gas, may emit fumes of europium oxides. So, yes, it burns pretty spectacularly. Gee, that's so true. So, oxide, so hydrogen sulfide? Hang on, I'm reading something. I'm getting caught in something because I'm Trying to figure it out. Superconductor. Hydrogen sulfide. I guess I can just show you what I'm looking at. Barium, blah, blah, blah. Fission product. Especially this. You can function at decays. 51. Half-life of 8.53 or 93 years. For Europium 154. .5 parts per million in fissions. Okay, I'm just okay, now I'm just reading stuff. So not found in nature. So it doesn't come found in nature. It's like I said, there's some Europium sulfate. See, the problem is everything has, so to get like clean, clear, pure elements is really hard, and it becomes really expensive. See, it says hydrogen sulfide. That's what I can't figure out. Anyways. Oh, got it. It gives off hydrogen sulfide gas. And that's what it's talking about. So yeah, it's flammable. It's a dangerous. It's in a fire diamond. And here's all the stuff. Okay. That's what confused me. I was looking at the hydrogen sulfide depiction and could not figure it out. So, that is our first look at periodic table. And I think they're cool metals. Most of them are used in magnetics. They are the so-called rare earths. They can be used as moderators for nuclear power generation, things like X-ray sources. So they're pretty cool metals. I'm a big fan. I also like their little cousins. And that was just kind of a brief overview. Oh, I wanted to hit this too. And I couldn't find it. So this is all the melting points and boiling points of these different metals and their ionization energies. So, like they were saying, they're all fairly similar. Like everything's fairly in a pretty good range as far as chemicals. I mean, even Europium, Holmium, and the are all very close in boiling point. So, and this is electron configurations, a bunch of other very deep and censorship units. Yes. Not in freedom units. One day you guys might adopt freedom units. So this has a bunch of information about the ionic radius and atomic radius. absorption of light. See, I mean, they're all pretty close, and that's why they're, because even on other areas of the table, elements that are grouped together aren't necessarily very close. So, so that is basically lanthanides. I think they're interesting. I like to play with them. I want to get more. And they are the rare earths. Why they're important is, like Xcomer said, a lot of them are produced in China. Well, the problem with that is we use them in a lot of industrial applications, medical applications, different things like that. And if we can't get to them and can't effectively mine them, then that becomes an issue. So, so it's one of those things where we need to do a better job of procuring them, or we're going to have to start synthesizing them, which is incredibly expensive and inefficient. So that is the show for today. And China don't play nice. Exactly. Yep, they're not very friendly. So this one I plan to also, invade China. That's what this was all about, Stevie. You got the point. I can't dump Impish because I'm not big enough. I can't dump until I'm monetized. Or I absolutely would. You want to drop a link, or I'm sure everybody can find their way over. So yeah, it's one of those things that we need to think about, because synthesizing them is not always possible. It's dangerous, it's expensive, and it's not very economical. So we need to start thinking about that too. I want to expand on this series. I really like the periodic table. Gonna do different groups. Gonna try to make it much more seamless, and maybe do some experiments around the way. So, some stuff where I definitely don't get styles on fire. Meteor mining, I haven't looked into it. I certainly can and get back with you, Xcomer. I would assume just based on what I know that they would be quite abundant in asteroids and meteors, just because of the nature of where they are in our planet on the crust. So it would be likely that they came from either some bombardment or stuff like that. So I don't know their prevalence, but I would say that, yeah. To put it simply, I'd rather go to Bennu than China. Just my personal preference. So, and for those who don't know, Bennu is an asteroid that we have observed. Jude, well, like 700 more bigger. That's a curious question too. Let me see. Okay, so let's read this political article. Okay, so we'll read these two. To hell with it. We'll just do it live. Do it live. Good questions though, you guys. Truly, really good questions. So, mining a 10,000 quadrillion asteroid. There's 7 million asteroids. They fall into 3 main types. Carbon, caseous asteroids, metallic asteroids, and mixed. I can't even pronounce words today, so you guys see it. Many of the metallic asteroids are composed of mainly nickel and iron, but also contain sizable quantities of important rare earth elements and precious metals, to include platinum and gold. A metallic asteroid, just 25 meters across, could contain as much as 30 tons of platinum, valued around $1 billion. 16 Psyche is a staggering 226 kilometers, 140 miles wide, and the most mineral-rich asteroid so far detected. It is speculated that 16 Psyche could be worth about 10,000 quadrillion, or 8,240 quadrillion euros. I love the conversion. To explore 16 Psyche in greater detail, NASA has approved the Psyche mission, which is scheduled to launch August 2022, and to my knowledge still hasn't launched. The spacecraft will orbit around 16 Psyche for 21 months while studying the asteroid using a number of different scientific instruments. 24% of all asteroids are thought to be composed of metals and rare minerals. While it's quite difficult to analyze asteroid composition from here on Earth's surface, there are another 10 asteroids have been identified as likely cost-effective mining targets to date. There are hurdles to overcome when it comes to mining, blah, blah, blah. So, that's just blah, blah, blah. So, to answer your question, Xcomer, yes, they are abundant in rare earths. That's what I'm saying. I've had rumble rants bigger than 10,000 quadrillion. I'm going to avoid this whole conversation that Impish and Jude are having. Three things. No, I don't trust them to do that. Two, DART is little course corrections, so we would have to send up multiple missions, which I guess is fine. But also, I wouldn't be comfortable within an orbit because then it's eventually going to come down. There's a lot of things that I don't like about that. I get what you're saying. But realistically, to get to the point that we could mine an asteroid effectively and bring it back, there are several technological steps that have to happen before that. So I think that's the thought. Hang on one second, guys. Sorry, I was absolutely freezing. I had to turn on the heat. My little heater. fly and mine it there. So it's in. It'd be incredibly inefficient to launch from Earth to go mine an asteroid. Just saying. Like, to get the materials up, to get, to do all the things that we need to do it'd be quite a challenge. So, to counteract that challenge, one of the things that we've been doing or sussing out is using the lunar surface, which takes far less energy to launch a payload from, to be able to do that. Also, there's hydrogen-3 on the moon, which is an abundant resource that could be potentially used as rocket fuel in the correct application with very little refinement. So, there's that aspect of it. There's also the financial aspect of it, where, I don't know if you know this, but these rich people like to make money. They like to keep it. And if you brought in, and I don't know what the platinum, hang on. Let me get this accurate. I know, parchment, blah, blah, blah. God, I hate... You know what I like? A good graph that actually has what the hell you need. So let's say there's a... Let's say there's 10,000 ounces, just for the sake of argument. There's probably more. 10,000 ounces of platinum. And per ounce of platinum, it's $1,800 an ounce. I know it's different than that right now, but just for arguendo. So that price is artificially high because, or it's high because of how much is available. Like, it's scarcity. It drives the price up. So if we were to bring in 1,000,000 ounces of platinum, then it's obviously not as valuable. So yes, 1,000,000 ounces of platinum could be, what did I say, 1,800? So $180 billion, I think, quick off my top of my head. But it's not going to be that, because you're diluting the market so much at such a quick rate that it would be about copper prices. You'd be, at $1 an ounce instead. So I know that's one of the things. They're artificially inflating the price. So I wish that'd be the best thing ever. Yeah, but there's other things that cause extinctions. No. You say I'm saying it all nice and innocent, but then you say Daddy Elon yum. Ask Blanders what Daddy Elon yum means to the rest of us. Oh yeah. Well, that's why it's so important to settle on the moon for the abundance of hydrogen-3 that's in the regolith. Wait, I'm way out of my league, or you're way out of my league? That confuses me. Well, now we're on to the Q&A, Greedy. This is the fun part. Yeah, I mean, it's in such an abundance in the Regulus that we could take a lot of it, and the moon would be just fine. What was the other question? Because I hear my kids, so they're probably They got off school today because there's a power outage someplace. That's stupid. Oh, why does China have? Okay, and I'm gonna have to go deal with them. Space elevator. Space elevator. It's more of a, especially with the amount of shit we have in the atmosphere. It's probably it's more of a dream than it is a reality. We should have learned by now. Those people would know. Well, not if NASA keeps delaying. And there's some conspiracy behind that because I don't get it either. We're supposed to be to the moon by the end of the year. And a permanent presence by 2025. And neither one of those are going to happen. So, I'm trying to figure out why. And then we'll wrap up because my kids are not down right here next to me. So, California's Clark Mountain Range is the only rare earth mine in the United States. The Mountain Pass Mine.
Well, I'm out to my work here. John! Oh, right.
This doesn't say why. China accounts for 62% of the world's rare earth mining, 85% of the rare earth processing, and 92% of rare earth magnets. I don't know. So I will look at. Turbine machine was made with cobalt and Samarium alloy that came from China. Yeah, I'm not entirely sure. Yeah, I'm not entirely. Let me see. Because they have all the mountains, but it says, as the country with one of the highest concentration of rare earth minerals, reserves, and massive processing capabilities. rare earths are a group of elements, blah, blah, blah. That's what we're talking about. Yep. Fence, da, da, da. Monazite and bestite. They are dispersed in low concentrations that are costly to extract from ore. Major reserves in the world exist in China, California, India, Brazil, Australia, South Africa, and Malaysia.
Chase, I can fit the last thing.
Seriously, dude?
Sorry, I didn't know you were on stream.
You
I
do,
wasn't
because I
really
told you,
paying
man.
attention. No, you told Chase.
China's reserves. So China's reserves are only estimated to be 30%. So they're not even the. What's up, buddy? Apologize. They're excited because we're about to leave. So, but so it looks like 70% are not. What I'm getting is that. Well, I don't even think it's that, Linda. I think it's the fact that they're. So it takes a lot of. It takes a lot of manual labor to bring it from these things. So I think that's the problem, is that the processing, China's the only people that can produce it in quantities enough to make it so that it's viable. Other than that, I think that there's certain places that we could foreseeably do it. Yes. China is using both slave labor and traditional labor that the United States just won't do anymore. So, so that's our downfall, unfortunately. Yeah, it's gonna be fantastic. So I think it's a bunch of different factors. So, ladies and gentlemen, that is going to do it for me, because I have to take care of these crazy children and final preparations on leaving. We will have the normal night stream 8:30 p.m. I will finish building my train, because I started last night with Kaiser, and it looks really cool. I'm really excited about it. And it's not going to be as long as traditionally other streams have been, but we'll have fun. So, we'll have fun. And then I will keep everybody posted on what the goings on for next week will be as well. So, I will talk to you guys all later. You guys have a wonderful day. And, oh, Impish, were you going to drop Hayden's link, or... I mean, you guys all know Hayden. You can go over there. So, I will. And I will intentionally send you pictures of me on the beach, just to antagonize you, Impish. Because you not love you. Alright, y'all. Have a great day. We'll talk to you tonight. Alright, bye.